Hello, I wanted to record this quick video to give you a run through on what sampling distributions are. This is a topic that is often kind of like just brushed over, but it's actually kind of crucial to the next steps of doing inference. So let's talk about inference and how this relates to sampling distributions. So inference is what we do. We have a population with some kind of unknown value. Let's call that P. Um, and we want to know something about it. How do we study it? We take a sample and we use that sample, and from it we get something called p hat. Let's just call that our sample proportion. And we're going to use that sample proportion to make inference about what this is. Actually, this is a very good estimate. This p hat we found is what we call a point estimate of p. Okay, so that's what we do. This is what inference is. But to understand inference, there's a related idea of sampling distributions. So here's what's going on with a sampling distribution. Suppose we have a population, and we don't just have one sample, but we have many. This is a very key idea. And from all these samples, maybe I have 10 samples, 1 up to 10. From each of these samples, I can get some value, p hat 1, p hat 2, p hat 3, p hat 10. And if I study these samples together, that gives me much more information about my population. In particular, I can take the mean of all my samples, 1 up to 10, and that gives me an even better estimate of my population proportion. Moreover, I can find the standard deviations of all these. And whatever that is, that tells me something about the spread of my data. So if I put all these guys onto a histogram, if I make a histogram of p hat I, I'll get something that looks like this. And we'll model it often as a curve where the middle, there's a theorem that says if I sample many, many times, the middle of that will actually be my population proportion. And then we look at the spread, we look at the standard deviation of p hat i's, and this tells me information so that I can determine what a plausible range is. If I go 2 standard deviations to the right, 2 standard deviations left, this tells me what close to 95% confidence interval will be of what we would expect to find in my population. So this will also tell me, say I observe something that's outside of this. Say I observe p hat here. That's either an outlier or maybe it's coming from a different distribution. Maybe I have a second population here with a different p hat. Sorry, a different proportion. And now I can look at differences. So this tells us with some kind of certainty where something's lying. So let's put this into practice. This is the theory that's going behind it, but what will this look like? Here's an example problem that I put together for you to practice this very idea. So suppose I'm sampling again and again. Let me make this bigger. I'm sampling again and again from some kind of distribution. I don't know what it is, but here are the values I'm getting. What we're going to do to understand this sampling distribution, notice these are just the values I'm observing. They're not, this isn't the distribution itself. These are just values that I'm observing. I can find out what the mean of this is. So I'm going to go here and just find a blank spot in R. And I can find out what the mean of these are. Let's see, 26, 0.3, 0.26 again, 0.24, 0.28, and 0.3. I can find out what that is. That's my data that I've observed. If I type it in correct there, bear with me. That's my data that I observed. What did I do wrong? Did I do anything wrong? I don't think I did anything wrong. Okay, so now I can find the mean of that, and I can find the standard deviation of that. So if I were to sample many, many times, this tells me that the middle of my sample is about 2.7 and the spread is 0.02. Why is this useful to know? This information can help me determine, well, if I want to go 2 standard deviations to the right of my mean, I can take this number and go 2 to the right times this number here, 2 standard deviations to the right, and I can go 2 standard deviations to the left. That tells me a pretty plausible range of values from this distribution. So I get a range of 22% up to 32%. That tells me the plausible range of what lies within 2 standard deviations of my sampling distribution. And now I can see, based off other information I observed, say I'm looking at a proportion from a different sample space, and I get 35%. I can say, wait, if it lies within this value, that means there's evidence it's coming from the same distribution. It's coming from something that matches what I've already observed. But if it's outside of it, that gives me evidence that this is coming from a different distribution, and we have to take note. There's something going on that's significant. We call this a statistically significant difference from what we've observed in this sample space here. Okay, so that's just some extra practice. You can practice this and get 100% on it. And this will give you a better foundation, I believe, for what we're going to do next in Lab 8. All right, we'll see you there.